All right, I'm going to take the 2.09 practice test for radical and polynomial operations. So here we go. Okay, let's look at question number 1 here. Simplify the sixth root of x times the sixth root of x times the sixth root of x times the sixth root of x. They give us 4 choices, but let's go through and take a look at that. Written it down here on paper. So the easiest way to simplify that, let's use our exponent rule. So let's change it. That would be x to the 1/6 if we write it as an exponent times x to the 1/6 times x to the 1/6 times x to the 1/6. And we know when we multiply exponents, we can add those together. So 1/6 plus 1/6 plus 1/6 and so forth. So that's x to the 4/6. 4/6 as a fraction is the same as 2/3. So it's x to the 2/3, which would also be, if we wrote it as a radical, the cubed root of x squared. So let's see if that one of those is our choices. Sixth root of x, the 4 times the sixth root of x. There it is, x to the 2/3. That was one of the choices that we had, x to the 2/3. All right, let's look at the next one. Rewrite 5 times x to the 4/9 in radical form. Okay, writing that on our paper here, and they want it in radical form. So the 5 is out front. It's not part of the 4/9 because there's not parentheses. If there's parentheses, all of that would be to the 4/9, but it's not. So it's going to be out front. So we just have x to the 4/9. Well, since the 9 is on bottom, it's going to be outside, and it's x to the 4th power. So it should be 5 times the 9th root of x to the 4th. Definitely outnumbered. There it is, first choice, 5 times the 9th root of x to the 4th. All right, rewrite the 8th root of x to the 3rd. Okay, so since the 3rd is underneath with the x, that would be on top of the fraction. So it looks like it's that second one, 3/8. It's hard to see, it's very small, I understand, but that's x to the 3/8. So x to the 24th wouldn't work. This doesn't work. That's the only one it is. Okay, simplify the 3rd root of x squared times the 3rd root of x squared. Write the answer using a rational exponent and in radical form. Okay, so let's write this on our paper. Okay, so let's rewrite that first to use our exponent rules. So x cube root of x squared would be to the 2/3 power. And it's the same thing. So remember, we can add those when we multiply. So it'd be x to the 4/3, which would be the 3rd root of x to the 4th. Maddie, did you get some words in there on that one? Also, the other option it could be, since this is x to the 4/3, that's larger than 1. So that's like x to the 3/3 times x to the 1/3. So x to the 3/3, that'd be just x to the 1st power. 3 over 3 is 1. So this could also be x over, and we'd have 1/3. It would be the cubed root of just x. These are the same thing, really, because x to the 3/3 is just x. So we're either looking for the cubed root of x to the 4th or x times the cubed root of x. See what choices they give us. No. Oh, there it is. X times the cube root of x. They've got it simplified, pulling out the x in front of the radical. All right. Divide x to the 3/5 divided by x to the 1/4. Okay, we know when dividing exponents means we can subtract the fractions. 3/5 minus 1/4. So what is 3/5 minus 1/4? Well, to subtract fractions, we have to have common denominators. So to get these denominators the same, 5 and 4, what do they have in common as we multiply up? It'd be 20 the first time, because 5, 10, 15, none of those are divisible by 4, but 20 is. 4, 12, 8, 16. None of those are visible, but 20. So if we multiply this times 4 over 4, that's just by 1, right? So we multiply that. That would be the same as 12 twentieths. This would multiply by 5 over 5. That's another way of multiplying by 1. So that'd be minus 5 twentieths. So this is 7 twentieths. So this would be x to the 7 twentieths. Or if they wanted it as a radical, that'd be what? 20th root of x to the 7th. We'll see which one of those is our choices. Either it's an exponent or a radical. There it is, x to the 7 20th as an exponent there. Okay, this one has a power to a power, x to the 2/7 raised to the power of 3/4. Well, in that case, when we have a power to power, we multiply the exponents. Multiply the exponents. So 2 times 3 is 6, and 7 times 4 is 28. So 6/28, which simplifies. We look at that. 6 over 28, we can divide 2 and make that 3/14. So its simplest form would be 3/14. So we're looking for x to the 3/14, which is the first choice, x to the 3/14. They really should make these a larger font, but it's visible. If need be, you can always make this larger on your screen. And you can see the 3/14 if you make it larger, if you make your view of your web page larger. So, all right, 3/14. Let's look at number 7 here. Multiply x to the 3/4 times x to the 1/5. Okay, so again, this is a matter of adding fraction exponents. Okay, so 3/4 plus 1/5. All right, since this is multiplying the exponents, we can add them. We need those to be, again, just like up here, we need them to be the same denominator, which would be 20. So this one we were subtracting, this we're adding. So 3/4 would be the same thing as 15 20ths. 1/5 would be 4 20ths. So this is 19 20ths. So let's see what choices we have on that. X to the 4/9, 3 20ths, 3/5, up 19 20ths right there. Okay, now we have simplify 49th to the negative 1/2 power. Okay, 49 to the negative 1/2 power. Okay, so if we want that to be a positive exponent, which we need to simplify, we move it underneath the fraction, and it'd be 49 to the positive 1/2 power, because that's how we make it a positive. We move it on the other side of the fraction. If this was 1 over that, we would move this on top of the fraction. But it's not underneath there. This is by itself. So anything to the 1/2 power, that's the same thing as 1 over the square root of 49. Because 1/2 power, 1 is the power. So 49 to the first power, the 2 goes outside the square root of. So this is the same thing as 1 over 7. So we're just looking for 1/7. And there it is, 1/7. That's what 49 to the negative 1/2 power is. Okay, let's look at number 9. Find the solution of the square root of x plus 2 plus 4 equals 6 and determine if it's an extraneous solution. So it has the solutions of 0 and 2. So we need to solve this and see if we have either one of those solutions and determine whether it's extraneous. Okay. So to get rid of the square root, we have to square both sides, but it needs to be by itself first. So the first thing we have to do is move the 4. So we have the square root of x plus 2 equals 6 minus 4. It's 2. Now we can square both sides. The square root and the square cancel each other out to where we just have x plus 2. 2 squared is 4. Subtract 2, x equals 2. Okay, so x equals 2 is the solution. Is it extraneous? Well, the only way to know that is to go back to the original equation and try it out. The square root of x is 2, 2 plus 2 plus 4 equals 6. The square root of 2 plus 2, that's the square root of 4, which is 2, plus 4 equals 6. 6 equals 6. That's a good solution. So the solution is x equals 2, and it is not extraneous. Not extraneous. It's an actual solution. All right, let's look at number 10. Find the solution of 3 times the square root of x plus 5 equals negative 9. All right, so working this out, again, we need to square both sides, but only after the square root is by itself. So we need to divide both sides by 3 first. So this is now the square root of x plus 5, because 3 divided by 3 is just 1. Negative 9 divided by 3 is negative 3. Now we can square both sides. Square, square. This becomes x plus 5, because the square root and the square cancel each other out. Negative 3 squared, positive 9. Negative 3 times negative 3. Subtract 5, x equals 4. But is that an extraneous solution? Let's go back to our original equation. 3 times the square root of x, which is 4, plus 5 equals negative 9. 4 plus 5, that's 9. What's the square root of 9? It's 3. 3 times 3 equals negative 9. 9 equals negative 9. This is extraneous. It's a solution, but it's extraneous. Remember, we could take the square root of negative 9 to be a negative 3 as well, but when checking our solutions for solving these rational equations, we always assume the positive value, which makes this extraneous. So, looking at our choices, x equals 4, but that's extraneous. Number 11. Here's another one very similar to what we've done, but there's an x on both sides now. X plus 8, square root of x plus 8 minus 6 equals x. So this is going to play out a little bit more complicated, but we can handle this. All right. Again, we're going to get this by itself before we square both sides. So we're going to add the 6. So we have the square root of x plus 8 equals x plus 6, because we can't combine those. One's a number, one's a variable. Square both sides. X plus 8 equals, what's x plus 6 squared? X plus 6 times x plus 6. When we distribute, we get x squared plus 6x. Then we have to distribute this one, plus 6x plus 36. So this is x squared plus 12x plus 36. So that's what that equals. X squared plus 12x plus 36.
Sometimes super intentionally.
Okay, we need to set this equal to 0 to factor it then. So subtract x and subtract 8. Subtract x, subtract 8. 0 equals x squared. 12x minus x is 11x. 36 minus 8 is plus 28. Okay, we need to factor this. You can use the quadratic equation. You can factor it. You can complete the square, however works for you. But looking at this, I can see this is x plus 7 times x plus 4. 7 times 4 equals 28, and 7 plus 4 equals 11. So that is the factorization of that quadratic. So that gives us two solutions, x plus 7 equals 0 or x plus 4 equals 0. So in this case, if we subtract 7, subtract 4 over there, x equals negative 7 or x equals negative 4. It could both be the solution. They might neither one be the solution, but we have to put it in to check to see if it's extraneous. The square root of negative 7 plus 8 minus 6 equals negative 7. Right? We're just substituting everywhere there's an x in the original equation. So negative 7 plus 8, that's the square root of 1 minus 6 equals negative 7. What's the square root of 1? 1. 1 minus 6 equals negative 7. Negative 5 equals negative 7. Negative 7 is extraneous. How about negative 4? Negative 4 plus 8 minus 6 equals negative 4. Again, just substituting in everywhere there's an x in the original equation. I'm substituting my solution. Negative 4 plus 8. Well, that's 4 minus 6 equals negative 4. Square root of 4 is 2 minus 6 equals negative 4. 2 minus 6 is negative 4. This is the solution. X equals negative 4. So we look here, identify all the solutions. All the solutions. It does not say the next one says find the non-extraneous. So this actually wants to know all the solutions. All the solutions are negative 4 and negative 7.
Hello, future Mr. Now, when this question wants to know all of the solutions, it's talking about all of the actual solutions when you discard the extraneous solutions. It does not want the extraneous solutions. So it only wants the actual solutions. Don't let the phrasing of the next question influence this one. We should only select the negative 4 and throw out the negative 7. I'll explain this at the very end of the video when I realize what it was asking for.
Because the next one asks for the non-extraneous solutions, which means we may be throwing some out. Find the non, and this doesn't want the correct solution. I'm sorry, this only wants the non-extraneous solutions. So we'll throw out the extraneous ones. All right, we'll see if we lift ourselves enough room to work this. Okay, get this by itself before we square it. Plus 5. Square root of x plus 6 equals x plus 6. Well, this is interesting. Square root of x plus 6 equals x plus 6. Well, let's see where that happens. Square those. So this is x plus 6. And this is the same thing we had up here, x plus 6 squared. So we know what it equals. X squared plus 12, x plus 36. Okay. So subtract the x minus 6. 0 equals x squared plus 11x. This time we have plus 30. Last time we had plus 28. 30 is 5 times 6, which adds together to be 11. So that's the factors. So this factors to x plus 5 times x plus 6 equals 0. So that means x plus 5 equals 0. So x equals negative 5 is one of our solutions. Or x plus 6 equals 0. So x equals negative 6 is our other solution. So there's our two solutions, negative 5 and negative 6. Let's see which one is non-extraneous. Negative 5 plus 6 minus 5 equals negative 5 plus 1. We have two x's in the original equation. We're substituting negative 5. Square root of 1, because negative 5 plus 6 is 1. minus 5 equal minus 5 plus 1. So 1 minus 5. Because square root of 1 is 1. 1 minus 5 is negative 4. Over here, negative 5 plus 1 is negative 4. So this one checks out. Put that in red so we don't lose it. That checks out. That's a good solution. But is this also? Let's see. Square root of negative 6 plus 6 minus 5 equals negative 6 plus 1. Negative 6 plus 6, that's 0. 0 minus 5 equals negative 6 plus 1. Negative 5 equals negative 5. Oh, that is also a good solution. So there's two solutions for this, and they are both non-extraneous. So we're going to select that one. Negative 5, negative 6, non-extraneous. Okay, our next problem is I to the 31st. We're supposed to simplify that. I to the 31st. So putting that on our paper, I to the 31st. Remember, we can divide 31 by 4, right, to figure out what that is. When we divide 31 by 4, we get 7 with a remainder of 3. We don't care about the 7. We only care about what is the remainder. The remainder is 3. Because remember, these repeat. I is square root of negative 1. I squared is this squared, so it's just negative 1. I to the third is the square root of negative 1 times negative 1. So it's I times negative 1, or negative I. And I to the fourth is I squared times I squared, or 1. Remember, these all repeat. And if we know what the remainder is, the remainder is 3. So it's the same as I to the third, which means this simplifies to negative I. Negative I, right there. It's our fourth choice. There's the possible ones you could have. I, 1, which is all the ones that are multiples of 4. Negative 1, we have a remainder of 2, and then negative I. All right, simplify this radical. And the radical is the square root of negative 100. So having that on our paper, remember, we can rewrite that as the square root of negative 1 times the square root of 100. Square root of negative 1, well, that's I. So square root of 100, that's 10. So that's the same as 10I, square root of negative 100, which is the last choice right there, 10I.
Not like what you prefer to have happen to them, Maddie.
All right, now we're doing some mathematics with complex numbers. So we're taking 7 plus I, and we're subtracting 6 minus 2I. So we've got that on our paper. Remember, when we're doing math with complex numbers, you've got to take the real part and do math with the real part. And then the imaginary part can only do math with the imaginary part. Like terms. These are like terms. They're both real parts. 7 minus 6 is 1. Remember, subtracting. 7 minus 6 is 1. I minus negative 2I. Minus a negative. Minus a negative. I'll say that a lot. Minus a negative is a positive. 1 plus 2I. So our answer is 1 plus 3I. That's 1I plus 2I is 3I.
Shed the old one, increase the size of the old one.
There it is. 1 plus 3I.
Or grow a new one underneath.
All right. Our next problem is multiplying complex numbers. 6I multiplied by 8 minus 3I.
Caleb, which one?
So let's switch over to our paper. Multiplying those. Well, that's simple distribution, right? Multiplying by both of them. So what's 6 times 8? 48.
Like following
6
somebody.
times negative 3i.
What would be a downside if it just
Negative
shedded its extra
18i.
skeleton? Shed it,
I times 8.
what would
And
be a
I
downside?
times negative 3i.
Think about it again. If I just shed my skeleton,
Oh, now this is I squared.
I start to have the
I squared we know equals negative 1. So this is negative 3 times negative 1 or positive 3.
there we go. Yep.
So this will simplify to positive 3. So positive
It
3.
hardens after.
So 48 plus 3,
Once you bring that new extra
51.
first,
Negative 18i plus 8i, negative
on
10i.
your step one, a new
That's what we're looking for.
skeleton is going to grow underneath.
And it is the first choice, 51 minus 10i.
So over on the right up there, we have
Okay, now we have some polynomials being added together. So let's see how that works. So much like the complex numbers, we're just looking at like terms. 6x squared, and I'm adding, well, I can only add another x squared term. 2x squared, 6x squared plus 2x squared is 8x squared. 11x, I can only combine other x terms with x terms. 11x plus negative 17x. So 11x plus a negative 17 would be a negative 6x. And I got negative 3 plus negative 4. Well, a negative plus a negative is a bigger negative. 8x squared minus, and that's it. We're done with it. Combining like terms. So 8x squared minus 6x. Don't get fooled by the top one. That's positive 6. Right there. 8x squared minus 6x minus 7. That's what we come up with. All right. Just a few problems more. What do we got? 23 problems. And we're on number 18. So we're almost done. All right. Now we're subtracting. Just like the problem above, combining like terms, except for we're subtracting, and we got to pay attention because they're getting a little tricky with this.
time for that.
Okay, so they're getting tricky for a couple of reasons. For one thing, they're subtracting negatives, which we got to pay attention, make sure we add when we subtract a negative. And the other thing, let's look at this. X third, what are we subtracting from that? Well, we're only subtracting other x to the third terms. Where's the other? There are none. This has no x to the third terms, so it just gets to stay by itself. It's just an x to the third term. All right. This is an x term. But wait, there's an x squared term being subtracted from it. How many x squareds do we have over here? There's not one, so it's 0x squared. There's a 0x squared in here. It's just not written. So when we subtract 2x squared from 0x squareds, we've got a negative 2x squared. So it just gets to come down. X terms. So we've got x to the thirds, x squared. Now let's check our x terms. Here's 8x minus negative 3x. We have x terms, but we're subtracting a negative. So that means that's going to add 3 more. And then we have 5 and a negative 12, but it's subtracting 5 minus a negative. Minus a negative. So that's our answer. They got tricky with this when they did an x squared over here and an x to the third over here, and neither one of them exist in the other terms. So those just come down as a subtraction. So x to the third minus 2x squared plus 11x plus 17. Well, 2 of these don't even have an x to the third, so we know they're wrong right off. But there's the one that we had on our paper. X to the third minus 2x squared plus 11x plus 17. All right, multiplication of a monomial times a polynomial. This is just a one-term expression. So multiplying this, we just distribute. And we only have one thing to distribute. So 3x squared times 7x squared. So 3 times 7, we'll write over here, save ourselves a little room, is 21. X squared times x squared is x to the fourth. Okay, now the next term, 3x squared minus negative 2x. 3 times negative 2 is negative 6. x squared times x is x to the third. Now, our last term, 3 times negative 4 is negative 12. And x squared times 1 is just x squared. So there's our answer. 21x to the fourth minus 6x to the third minus 12x squared. There's only one that has 21x to the fourth. I don't even have to look at the other terms. But those do match up. 6x minus. Oh, I wrote it down wrong. It was a plus 2x. I had it written as a minus 2x in mine. Correct that. See, those are pluses. So plus 6x. That's why that didn't match there. I wrote that down wrong. Negative and positive. But that's the only one that had an x to the fourth. So that was easy to determine that was the correct one. All right. Solve for the area of a rectangle whose length is x plus 4 and the width is x minus 9. Okay. Well, remember the area is the length times width. So if the length is x plus 4 and the width is x minus 9,
I know they call it a shell.
see,
It's not a shell. It's
areas,
a skeleton. Like
length times width,
have a ladybug,
length.
like, oh, look at its shell, right? Or a spider, you wouldn't say that you crush
x plus 4, x minus 9. We just multiply length times width. So we multiply x plus 4 times x minus 9. Distribute the x times both terms. So that's x times x, and then x times negative 9. Okay. Now we take the second term, the 4. Multiply it times both terms. 4x, 4 times negative 9, negative 36. Like terms. So this is the same as x squared, negative 9x plus 4x minus 36. So I'm looking for negative 5, x squared, negative 5x minus 36. Right there, x squared minus 5x minus 36. All right. Simplify x minus 1 times x squared plus 5x plus 2. Okay, so here it is written down. Simplifying it, we just multiply them together. We got to distribute the x and then distribute the negative 1. So x times x squared is x to the third. X times 5x is 5x squared. X times 2 is 2x. Now let's distribute the negative 1. Minus 1 times x squared is minus x squared, or minus 1x squared. Minus 1 times 5x is minus 5x. Minus 1 times 2 is negative 2. All right, where's our like terms? Those are both x squared terms. Let's see, this is an x term and an x term. And these don't have any other like terms. So it's x to the third. Let's take the two x squared terms, 5x and negative 1x squareds. So we have 4x squared because our 5x squared lost one. Then we have a 2x and a negative 5x. So negative 3x. And then the minus 2 on the end. So this is our solution when we simplify that right there.
Put it on there with the line segment. But it's what about
It's the bottom one right there. X to the third plus 4x squared minus 3x minus 2.
Yep.
All right, 2 problems left. Frank and Gertrude mow lawns for extra money over the summer. So Frank's income is determined by this function. That's 5x plus 15. That's how much money he makes, where x is the number of hours. All right, so for how many hours, he gets 5 times the hours plus 15. Gertrude gets 4x plus 20. All right. If Frank and Gertrude were to combine their efforts and kind of have a joint business, then their income would be adding their two functions together, f of x plus g of x. So let's create an, okay, let's assume Frank's going to work 4 hours. Let's not miss that in there. But we're going to create h of x, which is this right here, f of x plus g of x, and see, will Frank make more money working alone or by teaming up with Gertrude? If he works 4 hours, is he better off doing that by himself or with Gertrude? All right, so here's the problem. We need to create an h of x to see how much money would Frank earn there. We know if he works 4 hours by himself, 5 times 4 plus 15,
You have vertebrae in your back, right?
20 plus 15, so Frank will earn $35 for working 4 hours. We know that one. But the question is, will he make more if he teams up with Gertrude, which is h of x? So we need to take f of x plus g of x. We need to take 5x plus 15 and add 4x plus 20. Right? This is f of x. This is g of x. Well, 5x and 4x are like terms. So this is what h of x is going to equal. 9x and then 15 and 20. All we had to do is just add the two functions together, combining like terms. 4x and 5x, 15, 20. So now, if he works h of 4, 9 times 4 plus 35. Right? So 9 times 4 is 36 plus 35. So that'll be $71. $35, $71. But he don't get all of this because he's teamed up with Gertrude. She's going to get half of that. So what's 71 divided by 2 is $35.50. He'll make 50 cents more if he teams up with Gertrude. So team with Gertrude, and it's 9x plus 35. So we're supposed to create the function, and will he make more money? He'll make more money with that rather than working on, but only by 50 cents. So it's not really a big deal. All right, let's look at our last one. Given the functions f of x is negative 4x minus 1 and g of x is 2x plus 4, which operation, f plus g, f minus g, or f times g, results in the smallest coefficient on the x term? On the x term, the smallest coefficient. So this is a very specific question. So let's do the three operations and see which one has the smallest coefficient. Okay, so here's the equations. Negative 4x minus 1 is f of x. G of x is 2x plus 4. And we're supposed to do these three operations. So which one has the smallest coefficient on the x term now? Well, right now it's x. Negative 4 is smaller than 2. So look at the x term. All right, let's do these. F plus g. Negative 4x minus 1 plus 2x plus 4. I can put that in parentheses if I want to, but we're just combining the like terms. Negative 4x and 2x are like terms. So that equals negative 2x. Negative 1 and 4 is plus 3. So that's what that equals. And what's the coefficient on the x term? Negative 2. All right, so there's our first one. And that's on f plus x, or f plus g. F minus g is the other one they want us to check here. So negative 4x minus 1 minus 2x plus 4. Okay, let's be careful with this. Negative 4x minus 2x. We got a negative. We're subtracting 2 more. Negative 6x. Negative 1 minus a positive 4. Negative minus a positive is even, that's negative 1 minus 4, basically, minus 5. All right, what's the coefficient on the x term? Negative 6. So far, negative 6 is smaller than negative 2. But we need to do one more, f times g. So negative 4x minus 1 times 2x plus 4. So this we have to distribute. Negative 4x times 2x is negative 8x squared. I guess I don't need parentheses up front. Negative 8x squared. And you might get excited and say, hey, that's smaller than negative 6. This is not the x term. This is the x squared term. Don't let that fool you. Negative 4x times 4 is negative 16x. Negative 1 times 2x is negative 2x. Negative 1 times 4 is negative 4. So this equals negative 8x squared minus 16 minus 2 more. So these combine, negative 18x minus 4. Negative 18 is the coefficient on f times g. Let's see what choices they give us. Multiplication. Addition, subtraction, multiplication. Multiplication has the smallest coefficient on the x term. There you go. Let's turn it in and see how we did. See if we missed anything. Oh, 95.31. Oh, we have to go back and see what we missed now. Somewhere we made a mistake. It's all good. Oh, there it is. Let's see if we missed any others.
So if you're stuck, come look at mine.
Nope, that's all good. Okay, let's look at the one we missed and see what error we made on that. That was identify all the solutions. Okay, that's one that we checked and we determined that 7 was an extraneous solution. But when they wanted all the solutions, they meant to throw out the extraneous ones. So that's important to realize. Because here's the work we did on that one. And we went back and we said, this is extraneous, right? We said, this is a good one. This is extraneous. So when they say all the solutions, they mean all the solutions that work. Throw out extraneous. They want the ones that work. So I think that was a little misleading the way they phrased it, only because they followed this. Because this also is wanting all the non-extraneous solutions, because negative 7 should have been thrown out. Correct answer is right there. So I don't feel bad. I don't feel bad. We had it right. We just looked at it and the way they phrased it made us think they wanted both. So if it wasn't multiple choice, we would have said, here's the 2 solutions. This one is actually an extraneous one. And then that would have covered us. But since it's multiple choice, it's kind of hard to figure out exactly what they're looking for sometimes. But we did the best we could. I'm happy with that. When I look back at that, I said, okay, I don't feel that I didn't understand. I understood what was going on because I had the solutions, but I misinterpreted what they asked. It happens. That happens to you. Get with me. Email me. Hey, Mr. Brock, here's what this was. I had that and I did this, and I'd probably go back and give it credit. But this is a practice test. We don't care. It's not going to affect our grades. But yeah, anytime if you had that worked correctly and misinterpreted the way the question was asked, argue that. Bring it to me. I'm very lenient in those situations because I can see why you thought that, because I just thought that on this one. So, all right, that's the practice test. If you struggle with your practice test, hopefully this helped you and you're ready for the test if you got all this figured out. Catch you next time.